Dear students, last time we have discussed the important topic of measuring length of an object in motion and principle of simultaneity. In today's lecture, we are going to understand about the Galilean invariance of space and time. You can see in the below picture, there are two frames of references. One is frame S and another is frame S prime. As in previous lecture, we have kept the theme same, and you can see that the frame S prime is moving with a velocity v. Please remind that this velocity is a constant in nature. You can also see an object AB lying in frame S prime. The length of this object is, say, L naught. Now, please note that the object or the rod AB, or you can say L naught, remains at rest with respect to the frame S prime. Our motive is to calculate the length of the rod with respect to the frame S and with respect to the frame S prime, and we will like to show you that the length remains invariant. That is, the length do not change with respect to two different frames of reference. You can see from point O prime, the distance of the rod up to point A is marked as x1 prime. Then the distance marked up to point B from O prime is x2 prime. So if I subtract the final distance x2 prime from the initial distance x1 prime, I will get the length of the rod, and I denote it by symbol L naught. Let me take this equation as equation number 1. Now, in the second part, we would like to calculate the length of this rod AB with respect to the frame S. If we calculate it with respect to the frame S, then we can always use the equations of Galilean transformations to do this job. As we know from our previous lectures that the equations of Galilean transformations are these. This is the first equation, and this is the second equation. The difference between the first equation and the second equation is only that in the first equation we have marked up to the first point A of the rod, and in the second equation we have marked up to the second point, which is the end point capital B of the rod. Now let me substitute the values of equation 2 and equation 3 into equation 1 so as to get the distances from the frame S. So I can write it as L naught is equals to the value of x2 prime is x2 minus Vt minus the value of x1 prime is x1 minus Vt, where Vt is the distance traveled by the frame S prime in time t, and when we solve it, then this L naught becomes equals to x2 minus x1 because Vt will cancel out. If I denote this x2 minus x1 as L, then L naught becomes equals to L. This suggests that the length of the rod remains invariant. So please remember that the length of a rod do not change with respect to the change in the frames of reference. So the Galilean transformation of space is always invariant. Similarly, in the second part of the class, we can discuss this in terms of time. So let us say that an event, say a flash of light, occurs in the frame S prime at time t prime, and then again in time t2 prime. Then, as observed by the observer of the frame S prime, the time interval between the two flashes can be written as t naught is equals to t2 prime minus t1 prime. Then suppose that the observer of frame S records the time occurrence of these two flashes as T1 and T2, then we know that according to Galilean transformations in our previous lectures, we have already proved that T1 prime is equals to T1 and T2 prime is equals to T2. So we will replace this equation with the times of frame S to get it as T2 minus T1. Now you can see I am marking the equation of time with respect to S prime as 4 and marking the equation of time tau naught as equation number 5, which is the equation with respect to the frame S, and you can see that the both times are equal. Tau naught is equals to tau naught, and for further simplification, I write that this is the measurement according to the frame S and this is the measurement according to the frame S. The first is according to frame S prime and the later is with respect to frame S. So I hope you now well understood that both the for the spaces and time intervals, the Galilean transformations always remain invariant. In our next lecture, we will discuss the transformation of velocity and acceleration under the Galilean transformation. Thank you and have a nice day.